So significant figures and calculations. So it's great, we learn how to count significant figures. When we do calculations, the numbers, the number that we get, the result, needs to be rounded in a way that reflects the precision of the data, the measurements that were used. Just as an example, let's say I took a piece of wood that was 10 feet long, meaning between 9 feet and 11 feet. Just, yeah, it's about 10 feet long. And I divided that by 3. What's the calculator going to tell me? 3.3333333. So if I took a piece of wood that's about 10 feet long and I cut it into 3 equal lengths, are each of them 3.3333333 feet long? No. It's going to be an estimate. It's going to be more like about 3.3 or something. But how do we know which digit to stop at? That's what the rules for significant figures tell us. They tell us we're going to look at the number that we originally started with and the uncertainty that was in that number, and we're going to give this answer so that the uncertainty is reasonable. So that's what we're going to learn how to do. Sometimes we have calculations with multiple steps. You have to add these two things together, and then you need to divide something, and then you need to multiply something else. And we do not want to round after each step, because when you round multiple times, you can introduce error. So what we're going to do is we're going to just run it through, keeping all the digits that the calculator is happily churning out until we get to the final answer. The best practice then is to write the whole thing down and then go back and look, okay, what were the calculations I did and what are the significant figures, and figure out how many sig figs my answer should have and then round it at that point. So that's what we're going to do. So multiplication and division are related operations. They're really opposites of each other. And so they have the same rule for figuring out the number of significant figures. So the result of multiplication or division has the same number of sig figs as the factor with the fewest. So what does that mean? When we write things out concisely like this, sometimes it doesn't really make much sense. But if I wrote out everything I'm going to say, nobody would bother to read it. So what we're going to do is we're going to look at the numbers. So if we multiply these numbers, this is what your calculator is going to show you. And what we need to do is we need to look at 5.02. How many sig figs does that number have? 3. And 89.665, how many sig figs? 5. And 0.10, 2. Very good. The leading 0 doesn't count. The trailing 0 does because there's a decimal point. So we did that. Now what we do is we look and see which is smaller, 3, 5, or 2. 2. You just look for the smallest one. That's how many significant figures your answer should have. So this one should have 2. That would be the 4 and the 5. That means that we're dropping this place, and we need to follow standard rules of rounding. If it's less than 5, we're going to round down. If it's 5 or greater, we're going to round up. And so we're going to report that answer as 45. That tells us that there is uncertainty in the ones place. It would not be reasonable to think that there was uncertainty way over here when we've got this one number that's really kind of estimated. So let's do this one on the bottom. How many sig figs in 5.892? And 6.10? 3. Which is smaller, 4 or 3? 3. See, that part's really easy, huh? awesome at that. So that should have a 0 in front of it. 0.965901639. How many of those digits are we going to keep? 3. A leading 0 like that, that's just calling attention to the decimal point. We're not going to count him. So we're going to keep the 9, the 6, and the 5, and we're ditching this 9. The rest of them you don't even have to look at. Sometimes students want to take this and they round that up, and then round this down and that up, and oh, good grief. And then what's really sad is when doing that causes you to get the wrong number. Yeah, don't just chop those off. Those are gone. We're just going to look at this guy with the arrow, 9. That means we have to round up, and so we're going to give this answer as 0.966. Okay? So rounding, only use the first digit that's being dropped. Don't look at the rest of them. Round down if it's 4 or less, round up if it's 5 or more, and again, only round your final answer. Okay? So let's do these examples real quick. Perform each calculation to the correct number of significant figures. You should always bring your calculator. I'm fine with you not bringing your book. Bring your calculator. They're small, okay? And get to know your calculator. And if your calculator is not behaving, ask me. I am the calculator whisperer, okay? And I can get your calculator to behave because it's always your calculator's fault. It's not your fault, right? So I can help you with your calculator. So 1.01 times 0.12 times 53.51 divided by 96. And I'm going to write down the whole mess that my calculator gives me. 0.67556.375. Now, sometimes I make mistakes. Did I do it right that time? It's so easy to push one button wrong. I recommend doing calculations twice. If you get the same number both times, it's probably right. If you get 2 different numbers, go for best 2 out of 3. Okay, so that's the answer that my calculator gives. Write that down, and then how many significant figures should that answer have? 2. Because this one has 3, and that one has 2, and this one has 4, and this one has 2. So 2. Just because this is a whole number does not mean that it's an exact number. If you don't know where that number came from, that it was 96 pencils or 96 cars, then you can't assume that it's exact. So I'm going to keep 2. So what should my answer be? 0.068. I'm keeping the 6 and the 7. Sometimes I get students saying, oh, it should be 0.07. That 0 is not significant. I'm going to keep the 6 and the 7. I'm getting rid of a 5. 5 or greater rounds up. Any questions? The other one, 56.55 times 0.920 divided by 34.2525. The calculator just comes up with all these crazy digits. Did I do it right? Okay. How many sig figs should I leave in that answer? 3. This one's got 4, that one's got 3, and that one's got a lot more than that. So 3. I'm going to keep these guys. We're getting rid of this one. So 1.519. Oh.
No, you round up the one.
Yeah, brain fart. That's what my husband calls it. Yeah, I'm not keeping that 8. There we go. Ugh. Now, you do need to be a little careful. What if we had... What if we had this number and we were rounding to three significant figures? Do we round that to 153? No. You're selling your car for $15,288.90, but we'll just round it to $153, and that's what I'll give you for your car. Good deal, huh? For me, not for you. So we're keeping the ones place. No, that's not the ones place. That's the thousands place. We're rounding off to the thousands place. If you're rounding to anything greater than the ones place, you need to be really, really careful so that you don't change the value of the answer. The best thing to do in this situation is put the number in scientific notation and then round it. So 1.5289 times 10 to the what? 1, 2, 3, 4. I made my own separate example over here. Now, if I keep 3 digits and get rid of this one, I can round that to 1.53 times 10 to the 4th. And I won't get in trouble. But you may have turned off your common sense somewhere along the way. Dust it off, find the switch and turn it back on, okay? Because some of these things, you know, you get it wrong on the exam and then you look at it later and you're like, oh, duh, that was obvious. Well, that's what your common sense is for, to help you look at it and say, hey, wait a minute, that doesn't make any sense. I can't round 15,000 to 153, but I get students doing it all the time. It's a very easy mistake to make, but think about it. Okay? Don't just blindly do stuff. Think about it. So we're going to stop there, and we'll pick up on Thursday.